So in this video we'll talk about bagging. So in the previous section I've ended by telling you that trees, despite being quite flexible, they end up having high variance in terms of prediction, meaning that if you change the data slightly, you can get very different trees and eventually some difference in the prediction. So here I'm just going to do an exercise. I have the data set BMD, the one that we used before, so 169 measurements of bone mineral density, and I'm going to fit a tree for bone mineral density, so a regression tree using just one single predictor, age, but rather than using the original sample, the original 169, I'm going to bootstrap this sample. Okay, so I'm going to create a bootstrap of 169 observations sampled with replacement from the original 169 observations. Okay, and then build a tree. And I'm going to run this multiple times. So I'm just copy paste the code that I had there. So I'm bootstrapping, building the tree, and plotting the tree. So we have here the first tree that with a cutoff for age at the age of 67. So I'm doing again the same thing. So I'm creating another bootstrap. Now you see here the cutoff changes to 71. The structure of the tree is different. And if I run it again, and now the cutoff is 70, the structure again different. And if I keep running this, I get different structures. Okay, I'm not really showing you if the predictions are changing that much. But at least from this very simple example, you see how the structure is changing with different bootstrap samples. Now the question is, can we actually use this in our favor? And the answer is yes, we can bootstrap the sample several times, and for each bootstrap I can grow a tree, fit a tree, and then make predictions from all those trees and average across all the predictions, and that's going to be my new prediction. Okay, so this average prediction will tend to be more stable because it's based on an average, and this is called bagging. Okay, so the idea is the following, represented here in this figure. So we have the original sample, I bootstrap that sample, okay, I grow a tree, go again to the original sample, make another bootstrap sample, grow another tree, another bootstrap, another tree, and so on. Do this multiple times, okay? And now, once I need a prediction for an individual, what I do is make predictions across all these trees. So I make the characteristics of the individual run through all these trees, and each tree is going to make a prediction, and then I average across all the predictions, and this is my new prediction based on the bagged trees. Okay, so here I have the code to do a bagging of 50 trees, so nbag 50 trees on the dataset BMD. So I want to predict bone mineral density BMD using the predictors weight and age. Okay, using tree bag, so using the bagging function of in R, and I'm going to do this with 5-fold cross validation repeated 20 times. Okay, so I'm going to fit 50 trees, and now once those are fitted, I'm going to make predictions by fixing age. So I'll have to make predictions. I have to give a value for age and for weight. So I'm fixing the age to be 60, and now I'm going to make predictions for different weights from 40 to 90. Okay, and actually here I have represented the scatter plot for weight and bone mineral density, and I have 3 fitted lines, one for the linear model, the dashed line. So again, this is the predicted value from the linear model using weight and age equals 60. I have one single prune tree. Okay, it's probably just as one split, and I have the bagged predictions, which is this more flexible line here. Okay, and this is a comparison of the three methods. Notice, however, that actually I'm not really showing you the real power of both the trees and also the bagging, which is handling the interactions between the several predictors. Okay, here for representation I have to fix age 60, but for the linear model I'm assuming that we have an additive effect of the age and the weight, and for the trees and also for bagging, by consequence the bagged trees, I allow much more complex interactions between the predictors. So the advantage of the bagging is really that it stabilizes. It has the flexibility of the trees, but stabilizes the prediction, so they are not as variable as the ones based in one single tree. The disadvantage is now that your model is works as we call it in machine learning a black box. So you really don't understand what's going on with the 50 trees, right? So you build all these 50 trees, but what the model just gives you is the prediction based on the average across those 50 trees. So it will give you a better prediction than one single tree, but you lose the interpretation of the trees because now you have multiple trees involved in the process.